All right, ladies and gentlemen, guys, we have plenty to do. We are going to start off with differentiating inverse trig functions here. We're going to wrap this up with integrals that lead to these. So it's kind of a nice thing to combine naturally because these go together really, really well. Just a little forewarning. If you were to go back and look through your book or maybe look on the internet for some of these, you might find some different looking patterns for these. I do it the way that I do it simply so that when we get to integrals, things go together, things flow smoothly instead of feeling like we have to make adjustments and it seems like it's different even when it shouldn't be different. I'm trying to make it as smooth of a transition as possible. So I think my pen needs to charge a little bit. So I'm charging it. So we're only going to focus on 3 of them, and really, to be honest with you, we're only going to truly focus on 2 of them, arcsine and arctangent. Those are going to be our 2 main focuses for several reasons, one of which that's really all the AP test does, second of which you can cover all the sides of the triangle and all the combinations with those 2, and really arc cosine is not really any different from arcsine. Just like the derivative of cosine and the derivative of sine seem to go together really well, it's kind of the same way. So anyway, I'll just show these to you, or maybe you guys can kind of help supply some answers here, and then maybe we'll derive one of them and we'll jump in and try some examples. So does anyone, veterans, or anyone else for that matter, know the derivative of arcsine of u over a? Does Santi remember it?
Yeah, I think it's like, is it 1 over the square root of a squared minus u squared?
So, no. You're thinking of arctan.
That's arctan, so it's u prime over?
It's like
It involves, so we'll say
u over something. U prime over a.
it's u prime.
I thought that was 10.
U prime over something. What does arcsine involve? No.
C squared minus a squared.
So it's u squared minus a squared, but y'all are missing something still. What else are you missing?
Of u squared.
There we go. There's a square root. So it's the square root of u squared minus a squared. And the thought here is that u is simply some function in terms of x. U is 5x or x squared or 3x to the 5th minus 9 or whatever, right? U is some function in terms of x. Let's do arctangent real quick.
So is a then another function?
A will be some constant. Santi was really close to arctan a second ago.
I think is it a over a squared plus u squared?
It's close. That's close.
A times u prime.
There we go.
Wow.
It's u prime times a over a squared plus u squared for that one. And again, same thing. A is some constant. U is some function in terms of x. No square root on that one. And we'll look at why that is on at least one of these here in a second. And then arc cosine. Does anybody remember what arc cosine is? Closely related to arcsine.
Is it negative u prime?
It's just the negative of, yeah. So it's just negative u prime over the square root of, oh, hang on. Sorry, I wrote this down wrong. I don't know if you said it wrong and I just wrote down what you said, but up here it should be a squared minus u squared. Right here, I'll change that.
Oh,
That should be a squared minus u squared.
fair enough. Okay.
There we go. And I'm using my finger here. There we go. A squared minus u squared. So if you did get into one of these situations and you're like, oh my gosh, which one is it? Is it a squared minus u squared or is it the other way around? You actually can derive these derivatives in a number of ways. You could just use the inverse derivative of an inverse that we learned the other day, or one that I favor is triangles. So check this out. Which one do you want to see proved?
Tan.
Tangent? You okay with that?
Sure.
Okay, so here's how we set it up to prove this really is what it is. I'm going to set it up as y equals arc tan of u over a. I'm just going to say y equals that. And if y equals that, would you guys be okay with our goal being to find dy dx?
Yes.
That's our goal. So I look at this and I think, well, if we're going to try to find dy dx, why not just do ddx to everything? The problem is we don't really know what ddx of arctan is yet, right? We're proving this. So I'm going to rewrite this. How do I get rid of arctan? Because I really don't want that yet. I don't get rid of arctan with inverse tangent, just with tangent. Doesn't tangent undo arctangent? Yeah.
Oh, geez.
So I would write this as tangent of y equals, well, the tangent of arctangent, those would just cancel each other out, leaving you with u over a. And let's not forget that u is some function in terms of x, and a is a constant. So it might be wise to rewrite this as 1 over a times u. You don't have to do that, but that might be a wise move. Okay, so now I think that we have rewritten this in a much better way. I think this would be where we could do ddx of everything. So what's ddx? This is a nice implicit differentiation review. What's ddx of tangent of y?
Secant squared y times dy dx.
Okay, go ahead.
There we go. It's so true. Secant squared of y times the chain rule factor, which is dy dx. Okay, equals, what is the ddx of 1 over a times u? Remember, a is a constant, so 1 over a would be...
A times u prime.
There you go. You can start to see some of the pieces falling into place here. Certainly not all of them. So what you could do now is you could write dy dx, that was our goal, equals u prime over, oh man, this is in a bad spot. I'll write it down here. U prime over
Oh, shoot.
a secant squared of y. Right? If I just divide that secant squared y over, I would end up with this. And this would be maybe a point where you would say, well, gosh, I've got the u prime and there's an a, but it's in the wrong spot. But the secant squared y is totally wrong, right? We don't have it yet. So the question is, how could I deal with this secant of y in such a way that I only get u's and a's as a result? The answer is triangles. That's right. So I'm going to build a little triangle up here. I'll just come up here to the side and make a triangle. And I'm going to call this angle right here angle y. Can you guys read that okay?
Why? Is that why?
You see angle y up there?
Yeah.
Okay. Okay, so if I'm trying to do the secant of angle y, I know that secant is hypotenuse divided by adjacent. But I don't have a clue what the hypotenuse and the adjacent are yet. How could I fill out some of the sides of the triangle? What could I use? Yes, I've got this lovely arctan right here. Or I could even just use this, right? I could say tangent of y is equal to u over a, depending on how you want to look at it. So I then know for sure that tangent of y is opposite over adjacent. So I know those two sides. And here's where things start to come together. What's the hypotenuse? That's right, square root of a squared plus u squared. And maybe you start to think, well, maybe that's where the a squared plus u squared comes from. You're right, but what about the square root? Well, we'll deal with that. So then I come over here and I say dy dx equals u prime over a times, so let's go ahead and do the secant of y. Secant of y would be hypotenuse over adjacent. You guys okay with this? Square root of a squared plus u squared over a. But let's not forget that we're doing secant squared, right? So I think Jack just said all of that squared. Maybe I'll just come off to the side here. So this would be u prime over a times The square root and the squareds cancel out. All divided by a squared. And can you see how one of those a's would cancel with the other a? And you'd get a copy dot flop? I'm kind of out of room here, so I guess I could go up now, but I think maybe that final step you guys can all see. So the other two, the arc sine, or if you want to do the arc cosine, would proceed in a similar fashion. You'd define, you'd get an implicit equation, use implicit differentiation, do some triangle-y magical stuff like you all can do, and do some manipulation, and you'd eventually get to the same formulas. Okay? Meg?
So are we ever going to have to actually prove that on a test? Or is it just something we forget,
I think probably with these it's more of a can you use it situation. But at the same time, I would say, would it be unreasonable for me to expect you to be able to do any of these parts? Should you be able to do implicit differentiation? Yes. Should you be able to work with a triangle in trigonometry? Yes. Would I expect you to take 10 minutes on a test to try to do this? Probably not. I'd rather you try to apply this.
Yeah.
Or I'd rather you just use it real quickly to find some derivative, if that makes sense. Okay, any other questions, thoughts? If you're curious, I encourage you to play around with the other ones. I wish we had time to explore all of these sorts of things in class, but you know that's not the case. Okay, so if you would, see if you can take these and apply them to, I think there's just 2 examples. Am I right? 2 examples, 3 examples, yes. See if you can apply these, identifying your u and your a and your u primes and getting the correct form. There's all 3 of them. We'll do a little zooming in and checking up some answers a little bit. Work together. Try it out. See if you can put these together. Why is this? I appreciate your help, but I'm good. I'm good. So I'm hoping that on these, obviously it's pretty clear that we're doing arcsine or arctangent or whatever. The idea would be that you would identify the u and the a and the u prime correctly. So what did you all think about number 1 as far as the u and the a and all that stuff?
Yeah, 1.
Say again?
U equals 2x, a equals 1.
Yeah, u is 2x, a equals 1. So what's u prime? 2. Okay. So then as long as you have that formula in mind, this should be kind of a plug-and-play situation, right? So I would say that this equals u prime over the square root of a squared minus u squared. Sorry, I'm still getting used to this. I think it's working okay. What do you think about that? That make sense? Question?
So if a is a constant, can I set a equal to 1/2 and u equal to x?
Sure.
Like that?
Yep. You'll get like a slightly awkward looking version of the answer, but we should be able to reconcile the 2.
Right.
Yep, you certainly could via the copy dot flop thinking, right? 2x is the same as x over 1/2.
Yeah.
Makes sense? Forrest?
I thought it's square root 4x squared minus 1.
No, remember how I said, you might not have been paying attention when we went over those, how you guys like giving me input? Either you said it wrong or I wrote it down wrong. It's a squared minus u squared. A squared minus u squared. I went back and highlighted it and said, oh, that's wrong. Let's fix that. So I fixed it. A squared minus u squared. Yeah. All right. So then number 2, I guess Aiden, if you wanted to, you could do similar thinking with number 2, right? And that would be totally fine. I would say, as correct as your thinking is, I would say probably the more standard approach, like what I'm thinking about here, Aiden, is like multiple choice.
Yeah.
Like if you want an easy match with your multiple choice, you probably want to do it that other way.
Yeah.
So, okay. So if this is our situation, again, identifying our u and our a is important. Samuel, what do you think the u is for this one?
3x.
All right. Jack, how about the a?
5.
We put it all together with u prime. What do you think that is?
15.
Well, u prime would just be 3, right? But the numerator would end up being 15. I agree with that. So again, if we know the relationship, we know the formula, I'd say u prime a would be 3 times 5 over the square, or not the square root because it's arctan, over a squared plus u squared. So how about 15 over 25 plus 9x squared? Okay. Any questions on that one? All right. Last but not least, number 3, arc cosine of root x. Our u, Santi, would be what?
1.
No.
Root x and a is 1.
A is 1.
Wow, that's embarrassing.
And how about the u?
Root x.
Root x.
Or x 1/2.
Or x to the 1/2 would be
Ideal.
just as good. Perhaps you could argue that it's ideal. Because we're about to find u prime. So maybe it is ideal. So u prime would be 1/2 x to the negative 1/2 using the power rule. So again, this is sort of a plug-and-play situation. So this would give me negative u prime. So this would be negative 1/2 x to the negative 1/2 over the square root of a squared. And what's u squared? Just an x. So there's all kinds of things we could do to simplify this. We could do some copied out flopping. I got to be honest, unless I feel compelled to by like a multiple choice match, I'm not going to do anything with that. I'm just going to leave it as it stands. And I know for some folks, perhaps our 2 new ones, feels like we're breaking some sort of rule by not simplifying to a certain form. Does it really matter? It really doesn't. It really doesn't. Unless you have to match it, and then all of a sudden you got to do some algebra to get it there. Okay. How do you guys feel about differentiating arcsine, arctangent? Remember, arcsine and arctangent are your 2 big takeaways. There's derivative of arc cosecant, arc cotangent. We're not going to get too stressed about that. Okay, so then where we're going to finish with this, hopefully this will all look nice and coherent, is this. Integrating that involves inverse trig functions. These are integrals that, using our current skills, you wouldn't be able to do. So we have to introduce kind of these new lines of thinking. And I think one of the keys is to recognize the pattern. The pattern is leading to an inverse trig function. And I can kind of take, oh, now my finger's not working. There we go. Inverse. Sorry about the messy writing. This is my first time in a long time trying to write with my pointer finger. Looks like I'm a first grader. Actually, my first grade daughter writes a lot better than that. Actually, quite a bit better than that. Anyways, I'll try not to embarrass myself too much.
Not even so. Don't disrespect first graders.
Man, you're going to be let down. I'm sorry. Your view of me is going to... Okay. So when you look at these 2 examples right here, what I'm hoping is because of what we just did 5 minutes ago, you'd look at those and say, whoa, I think I recognize those. And we'll get into some of the details about how you could recognize these out of context. But what does that top integrand look a lot alike? The derivative of arcsine. So what do you think the antiderivative would be? It would have to be arcsine, right? Yep, so this would be arcsine of u over a, and then don't forget your plus c on the end. And what does the other one look a whole lot alike?
Arctangent.
Yes, the derivative of arctangent of u over a. So this would have to be, this antiderivative would have to be arctangent of u over a plus c. Now this is all presupposing a couple things. The biggest of which is, did Timmy mess anything up? Because if he did, if the du is wrong, maybe he's off by a factor of 5 or off by a factor of -7 or something, we might have to fix some issues. But as long as we can get to this form, we'll end up with these arcsine, arctangent antiderivatives.
So if you were just on like the big test, like the semester final, and you didn't know you were doing arctan,
Yep.
why would you not just bring it up?
Well, you would. You would maybe think about that. We'll talk about that in a second.
Oh, wow.
Because you might, and if you deal with it logically, you'll get stuck and say, ooh, maybe it's not what I was thinking. Maybe I try something else. Okay. In fact, why don't we do that with a couple of these? Meg, and I think the out of context thought that you're bringing up there is really good. I think it's really good.
Like the hardest thing last year for me.
So one of the lovely things about math, and this is going to sound not very profound, but it is profound. And if you can really grab a hold of this, this will really serve you well. Math is supposed to make sense. It's supposed to be logical. There should never be, now listen, there should never be a point where you say, oh, and we just like do some magic and we erase a couple things and there's the answer. It should always be, well, I added this over to the other side and here's why. And this comes over here and I did this thing here and here's why this makes sense. We should all be able to agree that yes, indeed, this is logical and makes sense. And so this will kind of get to Meg's question. So if you were doing some AP test, final exam, whatever it was, and you were in number 1 was on your test, maybe you would do exactly what you just said. Maybe you would say, well, I know sometimes we don't like fractions, so why don't we do this? Let's bring this up. This is sort of what you suggested. And we come up with this, and we think, okay, maybe I can do this. There's all kinds of pitfalls you could fall into, all of which are at their root simply not logical. So I've seen people do stuff like this, and so please, I'll write this in red. This is really bad. I've seen people do things like this as a next step. Well, because the square root of 4 is like a 2, and I'm sort of ignoring the minus sign, and the square root of x squared is x, and I'm kind of ignoring a few things. But do you see what I'm saying? Like, we know that, I know it's embarrassing. It's not logical, right? So maybe you wouldn't go that far. Maybe you wouldn't make that egregious of an error. But maybe you would make this egregious of an error. What if you just said, oh, I think the answer is 4 minus x squared to the 1/2 divided by 1/2 plus c. And you feel better about that because you know you didn't break any like square roots of a binomial rules. You can't distribute an exponent across a sum, that whole thing, right? What's so bad about this? Yeah, there's nothing here to match the derivative of the inside, but maybe you didn't know that. You know what you could do? You could take this answer and you could differentiate it, right? You could say, all right, well, let's differentiate this and see what happens. Wouldn't this be 1/2 times 4 minus x squared to the negative 1/2, still over this 1/2? And you'd be feeling really good about yourself right here, right? Except what did you forget? Times the chain rule factor of minus 2x. So times negative 2x. And this would be where you think, oh no, this does not actually match at all. So again, going back to Meg's original question, how would I know to select this procedure or select this other procedure? Hopefully, eventually, you see the pattern well enough where you don't have to put like gobs of thought into it. But early on, you might do some of these things where you logically paint yourself into a corner you can't get out of, and you think, oh no, this is not right at all. You know what? That means that you picked the wrong plan of attack, and you need to find a different plan of attack. So Meg, here's what I'm thinking. Maybe on this, I thought of some things, I thought of this, and I'm like, oh, this doesn't work at all. And the hope is that at some point you'd say, wait a minute. There's this whole other thing, this arctangent thing that we learned about. And doesn't this look sort of like arcsine? It's got the square root down there. It's got a difference in there. You'd start to notice some of those pieces and you'd think, well, gosh, maybe it isn't a flip up at all because we proved that it's really not. And you'd eventually arrive back at maybe it's going to be an arcsine. So does that make sense, Meg? But the hope is that if you did that enough times, you would eventually be able to see into the future enough where you'd say, ew, it's not a flip up. Maybe it's an arcsine. And you would like more logically jump to that more quickly. It's no different than when you do soccer. Like when you try to make some move and you do the same move like 4 times in a row and the defender steals the ball from you every single time, and then you figure out the right way to do it. Hopefully that means then you can just like do that every time. Does that make sense? Yeah. You don't have to like rethink it. You start to think, oh, well, when I see them do this, I do that. And you don't have to stop and think about it as much as you did the first time. Anyways, kind of the idea. So hopefully you arrive at this arc sign thing. You still have to identify what your u is and what your a would have to be. So what do you think the u would be here? It would have to be an x. Therefore, the u prime is 1. What's the a value? 2. That's correct. So then what you do is you do a quick check, and this is basically a Timmy check, right? You say that you think to yourself the antiderivative of u prime over the square root of a squared minus u squared is equal to arc sine of u over a plus c. This is what you're thinking. And so you're just asking yourself, is the numerator u prime? Because we know the denominator fits the pattern perfect, right? But does the numerator fit the pattern? For the first time in a while, Timmy didn't mess this up at all, did he? There's no mistakes. So I think we can immediately jump to the end and say the answer is arc sine of u over a plus c, and that's it. But you might have had to go through a little bit of a journey, like Meg said. To get there, hopefully the journey gets quicker and quicker the more you do it. All right, so maybe you're good to go with 2. Let's look a little bit ahead here. Maybe we try 2, I'd say 2, 3, 4. Yeah. Let's see if you guys can work through 2, 3, and 4 real quick. Yeah, this will work out. It's going to work out great. Time at the end on these, but I wanted to jump in on number 2.
Don't make fun of it.
So-
Went to high school there.
Now listen, I want to make sure, Meg, I want to answer your question here, because I think this is more directly at what you asked about. So when I want to kind of tell you the thought process that I like here. When I see something like this, that is a fraction, obviously, my first thought is it natural log? Is natural log going to work? So off to the side here, maybe I put a little note to myself. I say, is this natural log? In order for it to be natural log, doesn't it have to be the antiderivative of u prime over u in order to work? So in other words, the derivative of the denominator has to be the numerator. So I just do a quick mental check, and I say, is the derivative of 4 plus 9x squared, is that the same as the numerator?
No.
Nope. And it's not even close, right? We're off by a factor of x.
Yeah.
So the fact that we're off by a factor of x means that it's not natural log. And then the next thing I think of is it flip up? Do I need to take that denominator and flip it up? And this is what you asked about. And
Here you can't.
what's that?
Well, I understand why you keep that here, but I was saying more like when it's the square root, you could flip it up.
But it didn't work though,
Yeah.
right?
Yeah, that makes sense.
So you can like try it if you want. And of course, this one, if you tried it, why did you say that this doesn't work?
When you take the interval of it, it's going to be 0.
You get division by 0. Yeah. So you do a quick check there. And also, isn't the derivative of the inside 18x?
Yeah.
And the other factor is just a 1. And so again, you'd say it's not flip up. And so since it's not natural log and it's not flip up, it's either, at this point, it's either going to be arc sine or arc tan. And we go with one of those, right? So of those two, which one does this look more like? Arctan, yeah. So then, I don't know how this went for you guys. I'm looking at the top there. I'm thinking the top should be 6. Instead of 1, right, it should be u prime a. U prime would be 3. A is 2. I'll write it out here. If it's going to be arctan, u would be 3x. A would be 2. U prime would be 3. In order for this to be arctan, the top has to be u prime a, and u prime a is 6. So Timmy messed it up. So I would just go times 1/6. And I would end up with 1/6 arctangent of 3x over 2 plus c. What do y'all think about that? Veterans, is this coming back? Hey, Forrest. This is hard enough to do without getting distracted by Tai T. Yeah, let's just stay focused, okay?
Well, that was a good box.
I have a box drawing tool. Yep.
I like that color. That's a fun
It is a nice bright color. I like that too.
Magenta?
Okay, do you guys have any questions, follow-ups on this?
No, sir.
Okay, so if we keep going to number 3. You could run through the same thing with that Meg was talking about. You could ask, is it ln? Is it flip up? The truth is, you're going to get a roadblock on each of those. As you logically try to make it make sense, you're going to eventually come to a place where you're like, this doesn't make any sense at all. Of our other two options, arcsine, arctan, which one does this look like? Why not arcsine? There's not a square root, and it's plus instead of minus. Yeah, lots of good reasons. So if this is truly going to be arctan, what is my u?
X squared.
Correct. How about my a value? And so if u is x squared, what's u prime? So isn't the numerator supposed to be u prime a? So what should it be? Not just 10, 10x. And the top is x, right? We're off by a factor of 10. So I would fix Timmy's issue. I'd go times 10 times 1/10.
Yeah, we're not going to be here to save time.
Timmy's the last cars.
What's he going to do in the real life?
He's going to make a lot of mistakes.
He's going to become an English teacher.
Yeah, we'll leave math to the other folks. Okay, I don't know. There we go. Okay, what do y'all think? There it is in the nice box. What? I've got the box drawing tool.
Every single time.
It's amazing. So fast with really straight lines. I did just draw it, but I cheated. Okay, how you feeling? Is this okay? All right, so then the last one is this one down here. Number 4. This looks a lot like what? Looks a lot like arcsine. If it is going to be arcsine, what's the u? U is 4t, therefore u prime is? And the a value would have to be... So I put this in here at the end because this is a little different pattern than arctan. What is the numerator supposed to be?
4.
Yeah, it's supposed to be u prime, and it's not. So he's messed it up. So I just go times 4. Come on. And times 1/4. Did you guys get 1/4 arcsine of 4t over 3 plus c?
Yeah.
Okay. So our final topic, our final task is kind of along Meg's original question way at the start of class. It's what if we get something a little bit different looking, a little bit unexpected? So for example, I would say number 5. Maybe number 6. Here's what's going to happen with number 5. So check this out. First thing I would do with number 5 is I would see that 6 in the numerator and say, I don't want you there. I'm going to get you out of there. So I'll just come over here and pull that out. And I'll start in with kind of my analysis of what form is this. Don't let the cat out of the bag yet. Just keep it to yourself. Don't let the cat out of the bag yet. Hang on. I want us all to think on the front end here. Maybe you look at this and you say, is it natural log? In order for it to be natural log, what would the numerator need to be? Specifically, not an x squared, 2x plus 6. And I look at the numerator and it's just a lousy 1. I can't deal with that change. I can't deal with that mistake. I have the wrong form. If I were to flip up, please tell me that you wouldn't think about doing this, right?
No.
Right? We wouldn't do anything like this. That would be really bad news. That's not what a flip up is. That's distributing exponents again. Wouldn't you end up with this, where we've got x squared plus 6x plus 34 all to the negative 1? Look into the future. What's going to happen?
Divide by 0.
Division by 0, which would maybe make you think it's natural log, but we already just proved that it's not natural log. So at this point in the game, you'd have to say, well, it's not natural log, it's not flip it up, it's got to be arcsine or arctangent. What's the problem with that? It really doesn't look like that, does it? It isn't. I mean, what is it for sure not?
Arcsine.
It's for sure not arcsine because what's not there? There's no square root. So then you're left to think, well, is it arctangent? wouldn't you say by process of elimination, knowing that your menu of items is only 4 long at this point, doesn't it have to be arctangent? It has to be. But it's in the wrong form. Does anybody remember? Maybe this is where Forrest was going or Samuel was going. What do we have to do to get it to the right form?
Don't you have to like separate it so it's x squared plus 6x plus 9 plus 25?
What's that called?
What's that called?
Complete the square.
Completing the square. Yes, we got to complete the square here. So off to the side, maybe we come over here. And by the way, this is the easiest version of complete the square, thankfully. So here we go. What Sam said is all pretty good, I think. So what we do is we would write it as x squared. Oh my goodness, this is going to drive me insane. X squared plus 6x. We leave some space, and then we write plus 34. I put some parentheses there and there. And then, this is kind of the meat of it with the completing the square. I identify my b term, my b value specifically. And what is it? 6. What do I do to the b? Divide by 2, and then, so what do I get? Fair enough. So at this point, when I add 9 to the quadratic, I have completed the square, but I can't just do that. I got to subtract 9 from the outside of the parentheses. What have I done at this point?
Added 0.
I've added nothing. I've added 0, so I haven't really changed the value, just the form. This now should factor as a perfect square, hence the term complete the square. This is 25. This is where Sam's 25 came from, I assume. And I'm back to a form that actually might make some sense for arctan. So if you wanted to write it the same way, it'd be 1 over 25 plus x plus 3 squared dx. And this looks a lot like arctan, doesn't it? So if this is truly going to be arctan, I need to identify my u prime, and my a. What's my u? What does that have to be? X plus 3. Yep, that's my function in terms of x. What then is my u prime? 1. And my a value? It's 5. So for this to work, the numerator is supposed to be u prime a, which in our case would be 5 times 1 or 5. And it's a 1. So Timmy's messed this up, not surprisingly. So I just go times 5 to make that work, divided by 5 to accommodate my adjustment. And we're there. All I have to do now, please don't pack up yet. We have 3 whole minutes. I get 6 over 5 times arctangent of x plus 3 over 5. And don't forget the plus c. Yeah, after all that. Looks like a backwards D, but it's a C. It's really a C. Okay, you can see that there's one more hanging out there. We only have 2 minutes left. I don't feel compelled necessarily to do that. Guess what? It's another complete the square, right? It's slightly different. You just complete the square on the quadratic on the inside. And if you wanted to see that done, I mean, we might have time to do that tomorrow. We'll see. So tomorrow, I got 2 things to say real quick. Tomorrow, we have start of unit 4, which is it's like labeled chapter 8 in your notes. I'm obviously doing some jumbling around. Forrest asked about it last time. We'll come back to 6 and 7 later. But you're going to want to have that with you. Tomorrow there's going to be a little brief time of review, and then we'll be into some brand new, nobody, unless you looked ahead or whatever, nobody's ever seen it kind of stuff. So we'll all be on kind of a level playing field at that point. So have that stuff ready to go. Any questions on that part, Forrest? Go.
So we're not watching the intro video, we're just
Yeah, for this next unit, it's going to just be no intros. We'll just do it straight up, like normal. Question?
5.8.
So yeah, 5.8 is one of those bonus topics that in past years I did. Hyperbolic functions are kind of cool. With the subtracting of the 15 minutes per week thing, we just don't have time. Sad as that is. I don't have regular old class time to do that. It is interesting. It's actually a pretty common thing, but if you don't like that, you know what you can do? You can email and say, you can email the academic leadership and say, I wish we had longer classes or more of this or that or whatever. Whatever, I'd be fine with that. Hey, and then the other thing is...
What does it matter to you? That's true.
No, don't do it.